In this video, we are going to do problem number 6 from homework 9.1. But before we do it, we need to be able to see how a graph is a function or not. Just by looking at the picture, is it a function or is it not? And then we have to also review interval notation. So, how can we tell if a graph is a function? Or said another way, remember what a function is. We need each x to be sent to exactly one y. So how can you tell that graphically? So here's a graph. Okay? And what you're going to do is you are going to fix an x value. X values are vertical lines. For an example, say this is the x value, x is always -2. The fact that we have just one intersection means that that x value of -2 is just sent to one y value. I don't care where it's sent, I care that it goes to one place. So if I imagine moving a vertical line across my graph, I'm fixing x values, I'm seeing one intersection, I'm happy. But notice what happens right here. Say this is x is always +2, and I see more than one mapping. I see more than one intersection. We've got one here, here, and here. Let's make up some ordered pairs for these points. How about that x value is 2, the y value maybe is 4. Say this y value is 3, and maybe that one's a half. Because this vertical line intersects the blue graph more than once, we know we don't have a function, right? If we just looked at that domain element of 2 with these ordered pairs, 2 is being sent to 4, to 3, and to 1/2, right? To those y values. Those are different y values. This is big time, not a function. Okay? So even though the question is a little challenging, making sure that each x is sent to exactly one y, you can tell if you have a function quickly by seeing if you have any vertical lines that intersect your graph more than once. There's a name for this test, and it is called the vertical line test. Functions pass the vertical line test. Meaning all vertical lines, x values, intersect the graph exactly one time. Each x is sent to exactly one y. So here, all my vertical lines, all these fixed x values, intersect my curve just once. This is a pass. This is a function. Here's a fail. Here's all you need is one fail to have a fail. There's one vertical line and it is intersecting my graph more than once. Fail. All right, now with this information, let's go ahead and do question 6. Oh, we have to do the domain and the range with interval notation. We can do that. Okay, so is this a function first? All these vertical lines are intersecting the curve in just one place, so yes, this is a function. Now the domain is all of the x values. On this curve, x can be anything, and let me draw you a picture to make that a little clearer. Okay, so your image looks like this. If there were dots right here, they would be telling us that's the whole graph. But since there aren't, there are arrows here that are not pictured, meaning this graph goes forever and ever and ever in this manner. It looks like a U, and it just keeps going up and up and up and up and up. The x values, if I imagine projecting down onto my x-axis, I would get paint everywhere, right? If I put a little bit of yellow paint right here, it would fall. If I put a little bit of yellow paint here, it would fall. And it goes like this forever and ever and ever, right? Notice how this U keeps getting wider and wider, right? Takes a while, but we will get yellow paint everywhere on the x-axis. My domain is all real numbers. And in your interval notation, that's minus infinity to infinity, right? You can see it right there. Remember that order matters in interval notation. We always go small number to big number, right? And with your infinities, you always have a parentheses with them. You can never stop on an infinity. My range are all the y values. So now I'm going to be projecting to the y-axis. Here I see that y is 3. And all of these ordered pairs, we could put numbers on for them. We've got a 1, 4 on there, a 2, 8 looks like it's on there. We are getting all y values that are bigger than 3. Bigger than or equal to, because we've got a 3 right there. We've got x is 0, y is 3, or equal to. And the way we write that in interval notation is we have a bracket on the 3 because we're doing or equal to, y can be 3, and then the y values just keep getting bigger and bigger. They're approaching positive infinity. Always have a parentheses with your infinities. If you wrote infinity comma 3, that would be wrong, right? Remember, order matters. With interval notation. Okay, now let's figure out how to put those in to the computer. Okay, so for my domain, I'm going to click in here, get my arrow, and now there's new tabs, not just the basic tab. I'm going to click on intervals for the interval notation. And my domain was all real numbers going from -infinity to infinity. And I want the nice rounded parentheses on both those infinities, right? No brackets on either of them. So I've got -infinity. Got to get on the other side of that comma to positive infinity. Hit save. My preview looks exactly the way I want it to. My range, yellow arrow, intervals. My range was 3 to infinity, and I wanted to include 3. So I want to choose this one where I've got a bracket on the left and then a parentheses on the right. 3, comma, get on the other side of the comma, to positive infinity. Save. And there we have it. That's what we want. And yes, this thing is a function because it passes the vertical line test. I'm going to go ahead and hit submit. And we did great. Now we're not going to do question 7. Question 7 is very similar to question 6, but now we do have endpoints right here, meaning this curve doesn't continue and go on forever and ever. So we have this -5, 9. 9 is the biggest y value you can have. All right, in the next video, we will be doing problem 9.